Hello and welcome to another Zozin session. How about that? I should expect that shit to happen yet again. It's every day almost. Well, I mean, yesterday I take the day off, so it wasn't yesterday. So today we're doing yet another stream related to the wank tiles that we've been developing for several, I don't know how many, 2 weeks, 1 week, but we keep developing that shit. I can't stop. Like, I'm fucking addicted to this project. Holy shit. And why am I always addicted to the most useless project on planet Earth? I don't know why, maybe because I'm a programmer. So that's why the software industry is so fucked, is because all of the programmers are like fixated on useless shit. So that's probably the reason. Okay, so you can find the source code of this project in here if you're interested. Right, and so I'm gonna also put it in the description for the lovely people on YouTube. People on YouTube, I absolutely love you. You know that? You know that. People on Twitch isn't, but YouTube people, you know, I love you. So Wang tiles. I'm joking. I'm joking. I love everyone equally. I love everyone equally. So Wang tile source code. So, and essentially this is a project about generating, you know, pretty and not so pretty pictures, right? So it basically generates these patterns using a Wang tile technique, right? So, and let's take a look at it. Let's take a look at it. So do I need to fetch the latest shit? Maybe I need to fetch the latest shit. He loves us. yeah, I do love you, Kappa. Okay, so we have a little bit of a conflict in here. What the fuck? Who touched my source code? Why the fuck do I have a conflict in my source code? What the fuck? So do I have some sort of a changes in here? So here are the changes. And oh yeah, I was developing the flag system and then I extracted the flag system out of this thing. Okay, so what I need to do, I just need to clean everything up and then reset everything. So it's gonna be reset hard and then fetch the latest shit. I think I already fetched the latest shit, so the only thing I need to do is to merge the latest shit. So it's gonna be merge origin master. There we go. So after that, I need to rebootstrap my build system because git clean fdx removed my build system. Right, so now I have to rebootstrap the build system. The system has been rebootstrapped. It's now called no-buid. You know how Microsoft has like a GUID? We have a buid, but in fact we don't have it. That's why it's no-buid. Well, we're supposed to have it, but we don't have it, so it's no-buid. So what GUID stands for? I don't fucking know what GUID stands for. It's like a global. So B is a big unique identifier, right? So it's a big unique identifier. So maybe one day we're gonna actually maybe design our unique identifier, and I'm gonna call it buid, and it's gonna be a big unique identifier. It's not that difficult to be unique if you're big, if you know what I'm talking about. In a sense that if you have a lot of digits in your number, it is easier to be unique because you just have physically more numbers, right? 2 GB for 124, yeah. So imagine an identifier that is 2 GB. Well, considering the, you know, 64-bit architecture addressing, where you can address, you know, 2 to the power of 64 bytes, where in fact this is how many kilobytes you have, this is how many megabytes you have, and this is how many gigabytes you have. So this is how many gigabytes you may have in the memory potentially, and if we divide it by 2, that's how many buids we can have if a single buid is 2 GB. So this is how many you can store them on your machine. This is not how many you have, but this is how many you can store. Right. So, and in fact, the amount of booleans, if a boolean is basically a sequence of bytes, and the byte can be any value, right? So that means you have 256 combinations for a single byte to the power of 2 gigabytes. 2 gigabytes, essentially, here is 1 kilobyte, here is 1 megabyte, here is 1 gigabyte, and we have 2 gigabytes. So how many bleeds you can have in general, not considering the memory limitations. So you can have a lot of them, as you can see. It's still computing how many bleeds you can have. So so anyway, so let's actually kill the shit. So that's how many you can have. The Python isn't capable of computing that. Anyway. So yeah, I fetched the latest changes. So I was in the middle of fetching the latest changes. And what I needed to do, I needed to remove no build, right? And rebootstrap this shit properly. No build.c, and let's rebuild this shit one more time. So this is what our system is capable of doing. So here is Wang. So here are the parameters. You can control the parameters, and you can even do something like this. There we go. So this is the kind of animations that we can play, and so on and so forth. Right, but that's not really the point of today's stream. That's not really the point of today's stream. The point of today's stream is to take a look at one of the modules of this program. It has, you know, at least 3 different modules. STB image write we illegally stole from a person called Sean Barrett. Please don't tell him that I stole his code. I actually stole his code and put it into my project, and now this is my code. No, it's not my code. It's actually the code by Sean Barrett. So, but it's public domain, so I'm allowed to do whatever the fuck I want with it. So, yeah, you can find more information like in nothings.org/stb and stuff like that. So this is one thing. Another thing, we have a profiler. Right, and we have a thing that parses the flags and the main module that implements the whole logic. But there's another one called la.c. So, do you guys know what LA stands for? No, it's not Los Angeles. Okay, code. LA, yes. So it stands for linear algebra. Right, imagine a state in USA called linear algebra. Anyway, so this is basically a module where we have everything related to linear algebra. I documented this thing a little bit, but right now it only supports different vectors. Right, it only supports different vectors. So we have 3 kinds of vectors. It's 2-dimensional, 3-dimensional, 4-dimensional that store floats, and you have different constructors for these kind of things and different operations on these kind of things. And you may ask, and I won't blame you for that, by the way, why the fuck don't you use operator overloading, right? So when you're developing, you know, your own mathematical library, you usually use operator overloading because you want to use mathematical operators for the vectors. And the answer is, if you didn't know, my friend, operator overloading is a C++ feature, and C++ is a poo-poo language. Shots fired. We're programming in C in here, all right? So, yeah. And that's why we're not using operator overloading. So, here's the interesting thing. As you can see, there is a lot of copy-pasting here. There is a shit ton of copy-paste. Holy fucking shit. So it's violated keys so many times that it's, I don't know. We need to make like a band joke, but I'm not really familiar with this band, so whatever. It's actually not keys, it's don't repeat yourself. Yeah. The code is so wet, it's not dry. And dry is a don't repeat yourself principle, right? We're not following this principle at all, so that's why this code is moist, right? It's not dry. So, and what's interesting is that every time I need to add a vector of a different size, right, a vector of a different size, I'll have to copy paste all of the operations yet again. And furthermore, I also want to have a vectors that hold different types. For instance, this is float. It's a single precision number. But what if at some point I will need things that support doubles? Now I have to repeat 3 different implementations yet again. Right. You see what I'm talking about? You see what I'm talking about? And furthermore, sometimes I need integers vectors, right? Sometimes I need integer vectors. Like this. All of that has to be an integer. And I also need a different conversions between integers vectors and floating point vectors. This is insane. Holy fucking shit. It's a way too wet. Yes, it's such a wet code, my god. It's dripping all over the place. And I'm not even talking about memory leaks, by the way. So this has nothing to do with memory. This code doesn't even allocate any memory because it's just like, you know, combining things together, nothing particularly special. So in C++, it would have been rather easy to implement, I think, because you could have actually turned this into a template. Right. Right, so you will do something like template, so maybe something like type name. It doesn't even highlight this shit, that's how bad Vim is. Let's actually do LACPP. Vim is so bad, it doesn't highlight C++ keywords in a C mode. Like, what the fuck? By the way, so for some reason it's actually very slow. I don't know what the fuck with that. Is that a TeamUX? Sometimes TeamUX becomes so slow that I don't know what's going on, so I'm gonna actually restart TeamUX. It's actually not TeamUX. What if I kill the whole EuroXVT? Oh yeah, so apparently it's a problem with the EuroXVT. At some point EuroXVT becomes so slow it's incapable of actually zooming in and zooming out fast enough. And I don't know what's up with that. The Antonio, thank you so much for 6 months of tier 1 subscription. Thank you. And welcome to our epic EuroXVT club. That's right. So, yes. Thank you for feeding me with your money. So what I was talking about, does anyone remember? Oh yeah, Vim is bad. So Vim is so bad, it does not highlight C++ keywords in a C mode. That's how bad it is, okay? So let's go here. So this is going to be template, type name T, and then you will do something like vector. You can actually go as far as doing something like this, so you can pass the size in here, right? So this is going to be just V, and then you can have an array of this type, and here you can have a components, right? Components of this size. There we go. Isn't that cool? Isn't that cool? I think it's pretty fucking cool. And then you'll be able to do something like template type name T, size Tn, and then you can overload a particular operator, right? So let's say it's going to be operator plus, operator, oh, that's very interesting. So my mouth actually is in a very perfect position, making R look like N. Can you see that, chat? Look at that. I cannot zoom in because it's gonna ruin it, but it's actually in a very perfect position. So, and the problem is that I have a very declining sight, so I actually see worse and worse like every year. So, yeah, it especially messes up with my brain. So if I just, it's not N anymore. Anyway. So let's continue. We're gonna accept this thing in here, right? So this one is gonna be A, and this one is gonna be N. Look at how readable this code is. Holy fucking shit. So, and then I can just iterate through all of this stuff. Alright, so this one is going to be n plus I, and well, this one has to be b, of course, right? This one has to be b, a, c plus equal b, c, I, and then we can just return a. There we go. So, and that way you can have as many combinations as you want. You want a two-dimensional vector that stores float. There you go. Here's your two-dimensional vector that stores float. Do you want to have a five-dimensional vector that stores integer? Here you go. Here's that. And you would be able to actually, you know, do different operations on all of that stuff, right? So you'll be able to do this kind of shit because we overloaded the operator. But again, we're not programming in C++. Right. We are programming in C. We want to be able to like have a lot of these different combinations, but in C. And the question is, how can we achieve this kind of epic victory royale? What do you guys think? Do you have any suggestions on how we can sort of have the same, but without using C++ and using only C? Macros actually sounds like a good idea. So we could actually do something with the macros. Let's actually take a look at this shit. src la c. Okay, so let's do something like define vector, right? So we can have something like this, right? Maybe we could even have something more interesting, like vec name or maybe vname, right? So something like vname, where you could accept the type and the n. You can literally just accept like t and n, right? And then the thing we want to have in here, we want to generate the name of this thing, right? So this is going to be v, then t is going to be, well, we have to put n in here, and then we have to put t in here, right? And this entire thing will kind of generate as the name, and the thing we have to do in here is going to be, well, it's not particularly convenient because you have to put type like in here like float, but you have to put as f and 2. So it goes kind of out of the window, right? It goes kind of out of the window. So let's actually try a different approach, right? Let's try a different approach. We can define a macro, define vector, right? And again, it accepts this entire thing, and it will try to generate sort of this definition, right? So this is what it will try to do. It will try to generate this definition. So type def struct t tcn, right? And now we need to generate the name somehow. Okay, so the number is relatively easy to generate, right? So it's just n, and then I could only put t in here, but I want to actually have this as a prefix, so I need to be able in the preprocessor to take the first character of this thing, or maybe accept the character as a parameter, which actually adds like an extra work, and you don't really need to do that in C++, so let's actually call it type character, so TC. Yeah, there we go. So then instead of these kind of things, you could still define. You see, you could probably do that, but the preprocessor is very limiting. Preprocessor, first of all, is very limiting. Maybe I'm gonna put that as a list. Why not use macros? C preprocessor is very limiting, right? It is extremely limiting in what you can do with it. Unfortunately, fortunately or unfortunately, because there is pros and cons in C preprocessor being limited. So the pros are is that you cannot really fuck up. So if you make it like Turing complete programming language, people will go nuts with it, right? As soon as you make something Turing complete, people will abuse that to no end. Seriously. Look at templates in C++. Templates are accidentally Turing complete. They're completely abused, and the people wrote absolutely unreadable code. Again, readability is a very subjective thing, but they wrote a very complex code that usually has nothing to do with the problem they're trying to solve, and it's usually not necessarily needed to solve the problem. Let's put it this way. Let's word it without using these ambiguous words like readability and maintainability, because in my opinion, in 2021, these words lost any meaning, right? So that's why I'm not saying that the code that uses templates is unreadable and unmaintainable, because that doesn't mean anything. What I'm saying is that the code that uses a lot of templates is usually unreasonably complex, and you could remove that complexity and still be able to solve the problem. That's what I want to say. I think that makes more sense than throwing these buzzwords around. Anyway. So yeah, so you don't want this thing to be very powerful, because people will abuse it. People will abuse it. But at the same time, when you really need that power, you just don't have it. You just don't have it. And another interesting thing is that, okay, so you would probably generate, these functions with macros as well, right? So, and how would you generate this function? So you would probably have some sort of a macro that is something like, you don't even know where you're going to be having that, because the name of this function is not going to be put there directly. It's going to be a concatenation of several strings. You see what I'm talking about? Right, so if you're using macros to generate this function with this exact name is never going to appear in the code. The definition of that function is never going to appear in the code. So that means in your user code, right, in a user code, you refer to some function f to sum, but then in a library code, there is no direct definition of v to f sum. So essentially, if you are using a particular function and then you decide, I want to know how this function works, I'm going to go and grab that function within the source code. You won't be able to find it. You will never be able to find it. Do you know what I'm talking about? Type of is how you generate these functions probably. It's irrelevant to what I'm saying right now. And it's irrelevant to what I was saying before that. You see what I'm talking about? It is absolutely aggravating because you have a function, right? You have a function and you have no way to actually see how it's defined or find it anywhere. You spend hours and hours and then you discover that it's actually generated from a macro and it's just like a pain in the ass. Right, so the best solution would be to actually write manually all of the possible combinations that you may need once, right? So you want to like write all of the possible definitions of these vectors for different sizes that you may need. Usually you don't need bigger vectors than 4, right? And usually you don't need more than floats, doubles in integers, right? You just write them all of the possible combinations once in a big file. Luckily, the C compilers are very, very fast. So this file is not going to compile for too long. And then you just copy paste that file everywhere without ever worrying about it. And the next time you want to see how a particular function is implemented, you can just grab that function and find exact definition in that file. So you see, in the case of using macros, right? In the case of using macros, you basically shifting the convenience from the developer of the user of the library, from the library dev to library user, right? So it is convenient for the library developer to use macros and compress as much code as possible, but it is not convenient for the library user. You see what I'm talking about? And this is actually a common theme in software development. Developers quite often try to make the life of themselves more convenient, not the lives of the user. Right. For some reason, the comfort of the user is like a secondary thing. Nobody thinks about the user. Developers only think about themselves, right? They only think how to make their life more convenient, not the user's life convenient. So what if we actually go in an opposite direction? So what if we go like this? So let's actually do something that is not really convenient for us, but more convenient for the user. And that's basically where the idea of writing down all of the possible combinations come in. Right. So, but writing out all of that manually is not really convenient, even though we're not thinking about our own convenience, but the convenience of the users. So here is an idea. Let's actually write a code generator that generates all of the possible combinations and generate all of the possible combinations as a single header-only library and release that generated library. So the user of the library doesn't have to use your generator. they have to use your generated library. Right, and your generated library will contain everything you need. And if the user will ever need additional feature, you update the generator, generate the next version of the library, and you ship that version of the library. That way the user has all of the definitions directly defined in the file. They don't have to mess with your generator because you only need to generate this thing once, and everyone's happy. You see what I'm talking about? You see what I'm talking about? So that doesn't make sense. Does everything I said make sense so far? Because I'm not really sure. So yeah, it has everything. It has a convenience for the library developer, right? Because we're not messing with, you know, like manually doing all of these things. And furthermore, we're not using C preprocessor because C preprocessor is very limiting. We're going to use like a real programming language. And it is convenient for the user because the user can always look up the names of these functions with a grep or something like that. Makes sense, just need to make sure the source code, generated code, doesn't get out of sync. You just regenerate it, that's how we do this. It's a non-existing problem, you're making a problem. Would there be too many versions, combinations that might not be used? Exactly, and that's why in 2021 everyone is using an optimizing compiler that has that code elimination. Have you heard about that? Yes. There will be a lot of different combinations that are not used, but in 2021 we solved that problem. This is not a problem. Generator and a library going out of sync is not a problem because you just regenerate it. Unused functions is not a problem because we already solved that in the compilers. All right, so I don't know, let's go ahead and write this thing. Right, so again, we're shipping generated library. Right. Every time we're going to be making a release of this linear algebra library, we're not shipping the generator. Right. We're shipping the final thing. Right. It's like with a closed source software. Right. In a closed source software, you're shipping not your source code. Your source code is a template for generating a binary, and you're shipping a binary. Right, it's okay, so maybe in 2021 this doesn't make any much sense because who's using binaries in 2021? Right, let's put it this way. You write in a commercial service, or like a website, and what you're shipping is a webpack website, right, so which is like packed everything into a single like blob, right? So that's what you're shipping, but you're not shipping your original React JSX things, right? You're not shipping them. So you can think about your generator as the JSX for the Webpack blob that you're shipping. And the generated library is basically that. So that's how you think about it, and that's how you don't get out of sync, because how do you make sure that your JSX files don't go out of sync with your production deployed instance? How do you make sure? You just fucking make sure, that's your job. So, you see what I'm talking about? Does it make sense? I hope it makes sense. So, all right. So let's go ahead and do that. So, I just realized that I ran out of tea. So maybe we're gonna make a small break. It's only half of an hour. Maybe I should just, you know... Yeah, let's actually at least start the project. Hello, fellow GS kids. Yeah, exactly. That's how I felt when I was explaining that. This guy was fellow. How do you do, fellow web developers? Oh, it's like a website. Anyway, so let's go ahead. And furthermore, so another reason why I want to do that, by the way, another reason why I want to do that is that because I'm using this linear algebra library quite often in my OpenGL projects, right? And I always basically re-implement it from scratch over and over again, which is not particularly convenient. So it's basically the same situation as with string view, right? So I have a library for string views, And I've been re-implementing this exact library in all of my projects over and over again to the point that, well, I might as well extract it to the library and just copy paste it. So that's precisely the reason I want to do that.
The making certain TypeScript and JavaScript stay in sync is unsolved problem of computer science.
Gia, thank you so much for 26 months, oh my god, of tier 2 subscription. You're too generous to me. Thank you, thank you, thank you. Really appreciate it. Making sure TypeScript and JavaScript stay in sync is an unsolved problem of computer science. Exactly. It's freaking unsolved. It's really, really hard. But yeah, thank you so much. All right, so let's create a thing called LA, and let's just go in there. All right, so what we're gonna have in here? Maybe I will restart Emacs from within this development environment. Wangtile's life is very choppy on my machine, although it renders in 3 milliseconds. Where do I need to look? In the code. I don't know. So I don't know. You may try to report an issue with actually details about your environment, and maybe even recording a video demonstrating that it's actually choppy, and maybe doing some measurements and stuff like that, because we have an internal profiler. And what can I say? Welcome to the open source. You have to understand the context, like, right? So I was just trying to play with an idea of Wangtiles. I just hacked it together and I thought, okay, that's a cool idea. Look what I've done. And I posted the code. It's not a commercial project. It's not a commercial product. I have no obligations to support it or do anything. I just posted it. So I don't know where you have to look in the code, I guess. That's the only thing you have. I don't want to sound like an asshole, but the context is exactly that. So I don't even know what to say. Maybe I am an asshole. I don't know. Maybe I just should finally accept myself as an asshole and don't feel bad about that. Maybe. Anyway, so let's continue. So I'm just sitting here in my room, coding some stuff and shitposting on the internet. That's it. So that's it. Don't take me too seriously. Don't think I'm creating like a next revolutionary technology in there. I'm literally sitting in the middle of Siberian forest, shitposting on the internet, trying to wind up people. So that's it. Don't take me too seriously. Anyway, so let's create a main thing here. So what we're gonna have in here is gonna be that. So what build system are we going to use today? That's a very funny phrase if you think about it. What build system are we going to use today? Is that going to be makefiles, or is it going to be shell scripts, or is it going to be C code? So let's use Webpack. I don't know. I don't think Webpack is suitable for that. Autotools generates makefiles. I don't know. Anyways, so what we're gonna have in here. Okay. So let's generate a vector definition, right? So again, vector def, right? So and what we're gonna have in here, we're gonna have the amount of the size of the vector essentially, the type name, so const char type name, and again, so we have a kind of similar problem with as with the macros, right? But in here, at least, it's relatively easy to get the first character, right? Maybe that's precisely what we're gonna do in here, but it's making too many assumptions. Maybe at some point we're gonna generate a vectors where taking the first character is not gonna be sufficient enough. So what I'm gonna do something like const char type suffix, right? So we're gonna have two separate notions, like a type name and a type suffix. Infinito, thank you so much for 5 months of Twitch Prime subscription. Thank you, thank you, thank you. And welcome to our epic shitpost club. So anyway, I also think we need to accept the place where we're gonna be outputting this entire thing. So I'm gonna output that to a particular file. What is going on today? Do you guys like this idea so much? Like the idea of just generating C code instead of using macros? Thank you, but I do appreciate it. Thank you, Sibani, for 6 months of Twitch Prime subscription. Thank you, thank you, thank you. And welcome to our epic shit posting club. So, and essentially what we're going to be using, we're going to be just doing fprintf. So I'm going to be fprintfing this entire shell like that. So this is going to be type def struct, and here we're going to have the type, right, then the components, the size of the components, right? So I think it has to be ZU because it's unsigned thingy, right? And then we're gonna have a name, which is consists of the size and the type suffix. That's it. So, and then we're gonna have something like this. There we go. So after that, I just need to provide all of these things in here. So this one is going to be type name, then the size, then the type suffix. No, not really type suffix. Actually, I have to provide, yeah, I'm an idiot. I have to provide the size twice and then the type suffix. There we go. So that essentially will generate a single vector definition. So if we do something like gen vector definition and I want to print that to std out, and the size is going to be 2, the type is going to be float, and the prefix is going to be f. Will that generate a good type def? That's a good question. That's a good question. Let's see. So first thing we need to do, we probably need to compile this entire thing, right? So how are we going to call this? So somebody suggested a pretty good name for LA generator, lag, so I'm gonna steal that. I don't remember who said that, not intentionally, not because I don't want to credit anyone, but I actually genuinely do not remember. So thank you so much, random viewer in the chat. I really, really appreciate your idea. That's a very good idea. Thank you so much. Yoink. So now we're gonna be just generating this entire thing, and there we go. Cool. So what do we have in here? So this is comma, and now also I have to put a comma in here. I forgot a couple of commas. Okay. So if I try to run this entire thing, look at that. We generated our first line of code. Holy fucking shit. Oh my god, this is fucking beautiful. The first line of generated code. So what if we have like several sizes? One of the things we can do in here, by the way, that is kind of not possible in macros. So this is the first thing that is not possible with C macros. We can have fucking for loops. Look at that. Can you stupid C preprocessor macros have that? Can you fucking do that in C preprocessor? I don't fucking think so. Your C preprocessor cannot do shit. It's worthless. But here we have that. Anyways, so we're gonna have different sizes. So the amount of sizes is just like we're gonna go from 2 to, I suppose, 4, right? So, and I'm gonna be just incrementing them. And in here, I can just stick n in there, and there you go. We scale that code from 1 size to how many? Just a second, drum roll. There we go. So we have 3 definitions now. Easy. Fucking easy. What if you want to have 100 vectors? Fucking easy. This is the power, the unreasonable power of code generation. So, what if we have several types? We can actually have a list of types. If you know what I'm talking about. We can now even have some cool shit. The cool shit is going to be something like type definition, basically type def, right? So, and in a type def, we can have a type name and type suffix, right? We're going to have a list of all of the supported types. Supported types. There we go. And in here we're going to have a type name. You know what? We already know that it's related to the type. So there is no really need for this kind of prefix. I think it's a little better. Type def, name, suffix, go. So here we have a name, and the name is going to be float, and the suffix, right, the suffix is going to be f. So then we're going to have a double, and the suffix is going to be d, and then we're going to have an integer, and the suffix is going to be I. Maybe we can also have unsigned integer, and the suffix is going to be u, and so on and so forth. And you'll be able to add as many of them as you want, right? So, and then we can have some shit like, to be fair, I want to be able to quickly get the size of this entire thing, and I think I'm going to define a macro called array_len, which accepts the array and takes the size of the array and divides it by the size of the first element of the array, effectively getting the amount of elements of that array. So, and I think we can have, okay, so we're generating all of the possible like sizes of the vectors, but we can also now iterate all of the possible types of the vectors. So we're going to be doing something like size I less than, so it's going to be array length supported types plus I, right, there we go. And then I can stick that thing between the fours, right, and then here we can say something like supported types I, name, here's the name, and supported types I, suffix, Emacs. What the fuck are you doing, Emacs? I really don't like the name supported types. I think it's very, very dumb because the word supported is so freaking huge. Look at that. Look at that word. So it has 9 characters. 9 characters that convince nothing. They convince absolutely fucking nothing. So one of the things we can probably do, we can just rename it to something like types. There we go. So now it's types. Now it's a little bit better. So if we try to run this entire thing, there we go. We generated all the possible combinations of these motherfuckers. Can your C preprocessor do that? I don't think so. I don't fucking think so, mate. No. So that's pretty pow, isn't it? That's pretty pow. Furthermore, maybe we could actually make it completely global, and when you're referring to a particular type, right, we gonna pass an index in there, so we could easily communicate via the indices, so we can have something like yeah, index type. So let's actually see if this entire shit even compiles. You know what? I have an idea. What if we are going to do the following thing? You know, I really like, let's actually rename it to lag, right? So this is going to be lag. And then this is going to be lag like this. And in here, we're going to be generating la.h, which depends on lag. And we're going to be doing lag redirecting to la.h. So this is how we generated all of that. And on top of that, it would be nice to sort of test if this entire thing even compiles, right? So one way we can do that is basically generate O file, right? We're going to be generating O file. And it depends on la.h. So it's going to be cc o. I don't even know. Can I just do la.h? I don't think it's gonna work that well, but we can try. And let's go. So what does it say? Unsynced. Okay, so unsynced song. Unsigned. There we go. So, and I'm gonna go to the compilation of our, there we go, and everything seems to be compiling, and it actually compiled it into precompiled header. That is very interesting. So all right, but maybe that's fine. At least that this catches the errors, right? I don't really care about what it compiles into. What I care about is that whether it catches some like, you know, typos and whatnot, right? One of the things we can also do, we can make it a little bit more pretty. We can put like a new line in here. So it's going to be printf. Maybe fprintf std out, new line. There we go. Right, and maybe on top of that I could just print what's inside of this entire thing. Yeah, there we go. So we actually split them by their sizes. Right, so here are different sizes of the same thing. Different sizes. All right. So the next thing would be is to go ahead and start generating different operations like you know, sum, sub, mul, div, and so on and so forth, right? So let's try to generate sum. Okay, so I'm gonna actually maybe put this type definition in here. There we go. Here's the type definition, and here we're gonna accept the following thing again: vector sum, right? We're gonna accept the string, then we're gonna accept the size, and we're also going to accept the suffix and prefix and stuff like that, right? And so what we're going to be doing in here, we're going to be just simply generating all of that. So here we're going to be returning. Okay, this is not particularly convenient because now we need to generate a lot of types and a lot of prefixes, if you know what I'm talking about. So this is how it's going to look like. ZUS, right? So here's the ZUS. Then we have to do a similar thing like that, and then sum. And then here you will have to accept this type yet again and this type yet again, right? And that means I have to provide all of these parameters, like repeating parameters over and over again in here. So I'll have to do something like n type type suffix in this particular case. This is a type suffix, then n type suffix, and so on and so forth. I have to repeat it many times. So what I'm thinking is that maybe we need a function that returns the string that represents the type or the prefix, right? So maybe we could have something like vector type, right? And it will accept, I suppose it can only need to accept the size and the suffix. It doesn't really need to have the type, right? So because it is not involved in these things, like you only have v2f, and it should return some sort of a string. But here's the thing: as soon as you return char star, you have to think who's managing the memory for the char star. Who's managing that memory? So are we going to be allocating that on a heap and then returning that and then making sure that whoever called that function deallocates it correctly? Hell no! What the fuck? Hell fucking no! The reason why people hate C is because C programmers do this kind of shit. Really? So if you are a C fan and you're making functions that allocate something and return that, and you expect the users of this function to free this kind of shit, no, that's the reason why a lot of people hate C. Because it's fucking gross. You know what I'm talking? Like, who fucking wants to manage memory like that? It's like so error porn. It's insane. So yeah, we need a better solution than this. This is no bueno, if you know what I'm talking about. So here's the thing, I'm planning to actually pass around a lot of very small strings. Strings like vec2f, vec3i, and when we go into the matrices, we're going to have something like m2 by 2, d, and so on and so forth. We're going to be also generating matrices, by the way. So, as you can see, we're going to be like generating and passing around a lot of these small strings. And they're very small. What if for these small strings we're gonna introduce a special type, something like short string, And that short string is going to have the data, which is like 32 characters. It's kind of similar to the trick we used in LRU cache video. Do you guys remember this thing? LRU cache, where we knew that the size of our word is not gonna be too big, so we said fuck it, and we just implemented this type, which is just a word of 32 bits, and it simplified everything. It simplified generating new words, it simplified returning and getting them in the parameters, and it simplified even using these words as the keys in a hash table. If you never watched actually this video, I really recommend to watch it on my YouTube channel. So, all right. So, sorting daily LRU. There we go. So basically I made a small tutorial trying to explain how I understand LRU caches. You can watch this thing in here if you're also interested in LRU caches as much as I am interested in them. And I'm also going to put that in the description for lovely people on YouTube who also want to learn about LRU caches. So LRU cache tutorial in C. There we go. I just noticed a very strange thing. Every time you put in C in the title, it gets more views. So I do that not because like I like C or because I'm like really proud of programming in C. I'm actually not. I just noticed that every time I put in C, it gets more views. So that's why I'm putting it in C like that all the time. So now you know. Now you know why I do that. I don't know why. I cannot explain that. But for some reason, just I look at the stats. Oh yeah. So it's every time you put in C, it just like gets more views. People are interested in C apparently. Mark, it is what it is. It isn't what it isn't. It's just like you don't suck the dick of markets, you're out. So that's what you have to do. Anyway, so I'm gonna be returning a short string. There we go. All right. So and this function is supposed to return what? You have to do vector type and 2 and for instance type suffix, and it's supposed to return v2f. So basically it's supposed to concatenate these things, right? So and we probably can use something like ascend printf to do all of that, right? So ascend printf, let's see if we can do that. Ascend printf. I'm actually really curious why C is so popular. Well, I mean, why people are so interested in C, because I like every time I talk about C to people like IRL in person, everyone is just like they hating C because it's an old language and what the fuck, why are you programming a language? We should abandon it. And it's just like yeah, but at the same time a lot of people are interested in C. It's just like okay, I still don't know why, to be fair. Anyways, so we can use ascend printf to estimate how big the string is going to be, right? So this is what we want to have. It's going to be zu and then s. So the size, well, I mean, wait a second. This is the format. It has to be in the format in here. And then we're going to have short string result, right? It's going to be something like this. And the result, we're going to be putting that into the data. There we go. Well, I mean, first we want to estimate the size, right? So that's basically what we want to do. So I'm going to put null in here and 0 in here. And then I'm going to put n and type suffix, right? So, and that should return me the result size, right? The result size. We're going to be asserting a couple of, not assuming, but I mean, we're kind of assuming, but we're actually asserting a couple of things. We're going to assert that the result size is greater or equal than 0. Or maybe at least greater than 0, right? So that's what we're going to be assuming. And then that it is less, and it also doesn't include the null terminator. That's what's interesting. So we have to do something like +1, I suppose. Less than size of result data. Right, there we go. So, and if everything is okay in here, we can do ascend printf. It's going to be null 0 v zu s n type suffix. I mean, what the fuck am I doing? So it's going to be result data, and the size is going to be size of result data. There we go, and that thing should return something like the second result size. I wish I could call this n and this m, but n is already taken. So result size, okay. Actual result size. And we're gonna assert that result size equal to actual result size, and then we can finally return this result. So that's what I'm trying to do in here. To be fair, I'm probably gonna be doing this kind of shit a lot with different format strings and with different like sort of things, and I want to make sure that this entire shit crashes. If it overflows the short string, so I can go back to the short string and make it bigger if I realize that I'm going to have big types. But I don't plan to have a big type. So the biggest type that I'm going to have is probably, like in terms of the naming, is M4x4 F. So that's the biggest, which contains 5 characters. Even 32 characters is already overkill. So I don't think I'm going to be changing it that often. What I'm thinking is that maybe I need a special printf function that prints f into short strings. So, and then I don't have to repeat this kind of stuff over and over again. Right, I don't have to repeat this stuff over and over again, if you know what I'm talking about. So it's going to be something like short printf. Right, it's a short printf, and it's going to... How is it going to do that? Maybe it's gonna literally return that string. So maybe we're gonna call it short f. Yeah, there we go. So short f. And this thing is going to take the format string and also format everything, but most importantly, it is going to crash if the resulting thing is gonna be bigger than the size of the short string. Right. So, and this is where we're going to be using a variadic function magic. Are you guys familiar with variadic functions in C? So, yeah, it's going to be super fun. Trust me. Alrighty. So we might as well have something like a short string result. There we go. And then we're going to be returning the result. All right, do we have something like VSN print? Oh shit, we do have that. VSN, yeah, printf. This is the scariest printf function I've ever seen. This is like a final boss of printf functions. If you end up using this function, you're doing something very special. Yeah, you're doing something very, very specialized. You see, it's even the last one. It's the longest one and it's the last one. VSN printf. The point is, basically, S stands for that it prints into a string, N means that it prints into a sized string, and V means that it accepts VA list instead of variadic arguments. So basically you use V versions of the functions as a wrappers for wrapping around variadic functions, right? So, and that's precisely what we're doing. We're creating our own variadic functions, so we need a way to sort of do this kind of shit. Right, so, and we're using the final boss of printf functions. Okay, but we're gonna do that after a small break, because I'm already streaming for 1 hour, and I definitely deserve the cup of tea. What do you guys think? Did I deserve a cup of tea? Right. Yes. Okay, thank you. Free Fool, what's up? What's up? Big Anne. Okay. So, let's make some break, and you guys have... And I forgot to actually, you know, do the cut in the final YouTube video. So YouTube people are not supposed to see that we have a timer and stuff like that, but unfortunately now they will be able to see that. Okay, so for the YouTube people, I'm gonna do a cut. All right, so let's finish off this bad boy. Okay. So we need to to do pretty much the same thing as in here, we first need to estimate the size of, well, not really. We need to learn how to do variadics in C. Variadics. I keep forgetting how to use variadics in C, so it's one of the things, one of those features is that you do it once, and then once you've done it, you forget how to do that. All right, so the thing I can remember is that you have to include stdarc, right? There we go, we have a stdarc. Then maybe I'm gonna actually split my screen. And this one is very bright, so maybe I need to change the colors theme of my Emacs to be bright as well, so there's not that much contrast. Do you guys want me to change to bright theme? I can do something like customize themes. So what would be the bright theme? I think Adwaita is a bright theme. There we go. Does it look better? I think it looks pretty good. Actually, I really like this theme. Look at that. Isn't that lovely? Adwaita is like, it's bright, but it's not too bright. Right. If you know what I'm talking about. So it's kind of bright, but not too much bright. Right. Anyway. So short F. It's not going to be for too long. So we have to do VA list. So here is the args. And then we say that we start processing the args. And the args come after FMT. So that's basically what it means. When you say VA start, you basically binding the argument list, right? And you say that the arguments come after FMT. So that's basically what you say. So because I suppose the variadic arguments are passed via the stack, so you need to know where on the stack they start, and that's why you say, okay, they start on the stack after that argument, because arguments usually like passed via the stack. Right, and after you've done iterating through them, you say you're done with them, right? So it's a VA end, I think, yeah, it's a VA end. And every time you need the next argument, you do VA arg, and you provide it like this, and you also need to actually sort of convert it to a corresponding type. But the interesting thing, we don't really need to convert and even use VA arg, because the only reason why we are getting the list is because we want to pass it to this function, right? You see, it accepts this stuff, right? So that's precisely the reason why we're doing all this. All right, so here we accept str, but we only need to estimate things. We only need to estimate things. So I'm going to customize this thing. Zenbjorn can run this pod really, yeah. Treat this, no, don't treat it as safe. Okay, so we're back to the bright one. So do you guys like the bright theme? So should I actually switch permanently to bright theme? I actually don't mind. To be fair, with my vision, bright themes work a little bit better. I just see things better in bright themes, and I use dark theme just for you guys. I thought majority of people like dark themes. I like Borderland blue theme. We actually have a couple of themes in here, so it's going to be customized. To be fair, I think it would make sense for me to conduct like A/B testing. I could just take a look at the amount of views on the stream usually and with the bright theme and just compare that. So that will be the answer. I really like the old black and bright yellow theme. It's too contrasty for me these days, unfortunately. The one you used in your Haskell leads in your main channel. Yeah, I do understand that, but it's really difficult for me these days to actually use it. I'm sorry. All right. So speaking of blue, is that the one? No, it's not that one. Okay, let's go to back to Zenburn. Alright, so this one is going to be this, and I'm going to provide null and 0 in here because we just want to estimate the entire stuff. So it's going to be FMT, I provide args. So I suppose after that, so I think it has to be int. We have to end the arguments because this function sort of consumed the arguments. So we're gonna assert that n is greater or equal than 0, right? So this is the thing we're gonna assert, and another one is that n plus 1 is less or equal to the size of, to the capacity of the short string. Right, so that's the most important thing we need to do in here. So since we consume the arguments, if you want to go through the arguments one more time, so you're kind of forced to iterate through the variadic arguments 2 times. The first time you estimate how much memory it will take, and the second time you are actually rendering the string, which makes the process a little bit slow. But I mean, in this particular case, we don't really care about the speed. We're not making like a high FPS game or anything like that, so whatever. Nobody cares. So we need to iterate through this entire shit one more time. So might as well do something like this, right? So boom, and then we're gonna have the second time. So start args fmt, right? So it's gonna be va end. And the good thing about this code is that I need to only write it once, and then I'm gonna be just using short f that just generates a short string using printf syntax, and I never have to deal with this kind of bullshit yet, like ever again. So that's the beauty of this thing. Oh, we're probably gonna be like using n, so I need n to be available. So the idea with the blocks doesn't really work well. VSN printf. So, and we just provide the maybe we can actually do that only once, because sn printf will never overflow, if you know what I'm talking about. Because the thing we can do is just right away. Why didn't I think about that? I think I'm an idiot. Yeah. So the capacity here is size of result data. Just go ahead and do that. So it has to be greater than that, and n+1 should be equal to that. So that's basically what we expect in here, and then I can just return. Okay, so I don't know why I thought I need 2 passes. It's just fine with just 1. So there's no point to have 2 passes in here. Okay, so let's try to recompile the entire thing, and we have a bunch of asserts. So that means we need to assert.h. And there we go, So, what I want you to do now, right? So if I'm going to be generating this kind of stuff, right? So I need to have a vector sum. So I need to have a short string, and this is going to be a prefix, right? So this is going to be a prefix, and it's going to be short f v zu s, right? So it's more of an OP prefix, right? So this is more of an OP prefix, operation prefix, and this one could be a type, right? And it's going to be n and type suffix. And similarly, we can have something like this, and there we go. So we have type and OP prefix. Now to generate a function, right? To generate a function, we're going to do stream. So here we're going to be accepting the, here we're going to be putting the type, right? Then we're going to have OP prefix. Then the name of the operation. Then the type a couple of times. We're going to accept A and B. And there we go. I'm going to even put like a semicolon here just to see how it goes. So, and in here, first one is the type, so I get the data, and then we have the OP prefix, so I take the data and then type a couple of times as well. There we go. So that kind of like reduces the amount of arguments that we have to put in here, right? So I think it's a little bit better now, right? At least it's a little bit more readable. Okay, so then we do again vector sum, and we can try to generate all of that. So how are we going to be generating all of this? We can probably just, you know, pull it in here. So I'm going to just generate sum for the two-dimensional vector std2. The type is going to be float, and the prefix is going to be f. So maybe this kind of thing should accept straight up type definition, right? So you see we have a type definition because you always have a suffix associated with the type name, and you don't want to end up with a situation where it's not particularly true. So maybe I'm gonna actually accept type definition in here. There we go. Okay, that's actually not a bad idea if you think about it, right? So because you want to always keep the suffix associated with the type name, right? So that makes sense, I think. What does LA stands for? Linear algebra. It stands for linear algebra. So, so here's the type suffix, type name. So this one is going to be type def name, type def suffix, right? And this one is a type def suffix. This one is a type def suffix as well. All right. And I think we are ready. So, and in here, because of that, it becomes kind of strange because I now need to know, where float is located in types, so I can just do something like this, types 0, and I have to know that 0 is a float type, which is not particularly convenient. You know what I'm talking about? It's not convenient. I have an idea. What if we introduce enumeration? This is actually a pretty pogue idea, believe it or not. So because of the enumeration, we won't need this array length. So we can do something like enum. So type def kind. I don't know, type def type. Let's call it type def type. I think it's a pretty good name. Type def type, and we're gonna have type def float, which is 0, then double, which is gonna be 1, int, unsigned int, and then we're gonna have count type defs, right? So, and here we're gonna have a static array, count type defs, right? And now I can just have designated initializer for type def this thing, like this. And this one is going to be float, int, it's actually double, unsigned int, and then, okay, so I can also align everything by equals, there we go. So now, if I want to actually generate for the type float, I can say type def float, because I have an associated enumeration with that, and with designated initializers, we make sure that they're associated with the right things. Okay, look at that shit. Isn't that epic? Isn't that epic? I think it's goddamn fucking epic. So now, since we don't have array length anymore, one of the things I can do is just count type defs in here, and this one is going to be type def type, right? So, and boom, there we go, that's cool. And I don't even have to do this kind of shit anymore. I can just iterate through the types, and I just can pass types there. Yep. The count type is quite clever. I mean, it's a common trick in C, actually. But I do agree that it's clever, but it's not my idea. I actually stole it from somewhere. It's like a basically common wisdom in C. If you programmed in C long enough, you start to pick up a lot of these kind of tricks, and these tricks sort of circulate around C community. Right. So unfortunately, there's no like a single book where all of these tricks are sort of collected. And yeah, it's just like on the level of rumors, like you have to be in a C community to kind of like know these things, unfortunately. Why do you change it to static array? To make it static. All right. So what do we have in here? So I actually forgot comma, and we have a type. And why do I forget commas these days? Okay, look at that. Look at that shit. Look at that shit, bruh. So that was pretty pogue. Not gonna lie. So maybe we can go even further. All right. Does it even compile? It even compiled everything. So if I forget a semicolon, it's not gonna compile. You see? It will tell me that, bruh, you forgot a semicolon. So because we constantly check on each recompilation. So the whole process, the first thing it does, it compiles the LA generator, right? Then with LA generator, we're generating the LA, and then we're compiling LA to make sure that there's no compilation errors in there. So that's pretty much the thing. Okay, so let's go C. So this is only sum, but we also want to implement the implementation. Implement the implementation. So let's actually go ahead and do that. So we're gonna have this thing, right? And then we're gonna close this entire thing. So in implementation, we're going to have like a for loop, 1, 2, 3, 4. for size ti, then I less than zu, and basically it's going to be the size of this entire thing. We do know the size of this entire thing, and then plus plus I. So, and what we're doing here is essentially a dot ci plus equals b dot ci semicolon. Cool. So, and after that, we basically return a. So that's the implementation. So sum effectively, yeah, just uses this operator, right? That's what it does. It just effectively uses this operator, and it didn't work because we don't have a size t in here, and I forgot a couple of new lines. Okay, so first of all, we need to fix the new lines. The idea of constantly recompiling the header was actually pretty good. I really like this idea. And where is the other thing? Maybe I'm gonna do auto revert on la.h, if you know what I'm talking about. Auto revert mode. There we go. Cool. So this shit does not compile because we don't include the standard header, right? So maybe the one thing we're gonna do in here is again includes, right? So, but we're gonna generate them only once. So maybe because of that, I'm gonna just do fprintf stdout, right? And it's gonna include stdlib.h. There we go. So, and we don't have to worry about that anymore. There we go. And it works. Look at that. This shit works. Holy shit. So might as well put a new line in here. There we go. So if printf, cool. So now everything is working. Everything is working. We want to generate this kind of shit again for all of the possible types, for all of the possible sizes. Right? How can you do that? For all of the possible types, for all of the possible sizes. So you want to wrap it in here. Like so. So, and the size is going to be something like this, and this is going to be types I. There we go. And on each of these things, I think it would make sense to actually put a new line, right? And look at that. We generated all of that shit for all of the possible types, for all of the possible sizes, and it compiles. There we go. Can your C preprocessor do that? And it's actually super readable, right? So, yep. So here's the sums. Oh, it uses 2 everywhere. What the fuck? Why the fuck does it use 2 everywhere? Oh shit, this is because I didn't provide the arguments. Okay, so let's actually quickly provide them. So this is gonna be n, and I think that's the only thing that matters in here. There we go, look at that. It uses 4, 3, and so on and so forth. So everything seems to be okay. Nice. Nice. But here's an interesting thing. What if I need vector sub? Vector sub. So essentially, I'm kind of starting to repeat myself, right? Because I need to do literally the same thing, right? I need to do literally the same thing, but with a different suffix, operation suffix, and a different operation. So that means we want to actually abstract out this generator. We want to abstract out this generator. So let's do something like void again vector op, right? So, and in here, what it can accept, it will accept the well, the place where it's going to print all of that. So it's going to be vector op, the type definition and such, right? So here's the type, like size and type definition, and it needs to accept the op prefix, op suffix, right? It's actually accepting op suffix. So there is a prefix and there is op suffix. And on top of that, it needs to also accept the operation itself, right? So maybe we're going to call it operator. Maybe just op, right? Because operator could be taken in C++. So we're basically making this entire thing more abstract. where we also abstracting away this thing. So you have OP prefix, and also we have OP suffix. There we go. And then in here, we also have something like this operation. There we go. So this is going to be n, and then I'm going to put OP in here. So OP sum is essentially more general, more specific, I would rather say. Again, vector OP, right? So it's a stream and type definition. The OP suffix is going to be sum, and the actual operation is plus equals. There we go. So that's basically what we're going to have in here. So it's a sum and plus equals. Let's see if it's going to generate anything. Cool, I think it did. So furthermore, this is such a thin function that I think it would make sense to remove this thing and just inline it directly, right? So let's just inline it directly. But now it enables me to actually simultaneously generate a sub function, which is basically minus for all of the possible sizes, for all of the possible types. And it didn't really work that well, because why? So the stream is stdout, type def is types I, and that should be it. And there we go. So we already have a lot of lines in here, but here we generate a sum, which is plus equals, and the sub, which is minus. And it actually, since it's all generated, right, it eliminates the copy-paste typos, right, if you know what I'm talking about. So, and on top of that, you can generate the other operations, right, so something like multiplication, right, and maybe even division. There we go, multiplication and division. So there we go, so we generated all of them. Will this lib be used in some of your existing projects? This is a wrong way to think about it. If I'm extracting a library, usually, that means I already use it in a lot of my projects. So this is the reason why I created such things as a string view. I already explained that at the beginning of the stream, so I recommend to watch the beginning of the stream. So the reason why I extracted string view is because I ended up, I realized that re-implementing this thing in all of my projects over and over again, so it would be better to basically write it once and copy paste it. So the reason why I'm using this library is because I keep re-implementing it in all of my projects. So it will be easier for me to do that. So, and here's an interesting thing, we're starting to repeat this kind of stuff. In a similar way, we are repeating the types, names, and type suffixes, right? You see, we were repeating this kind of stuff, and we thought, well, it would be nice to have an array of that. Well, you know what I'm talking about? Right, so maybe we need to introduce something like operation definition. So we go in a layer further, right? We go in a layer further, and we're gonna keep going deeper and deeper. So the C preprocessor, by the way, whether to use a C preprocessor for this kind of stuff, C preprocessor can't even do a fraction of what we're doing right now. It can't even do like a small fraction. We're having like a lot of compression and a lot of abstractions just to generate this library. It's insane. So it's not even feasible in C preprocessor, and is it even feasible to do this kind of shit in C++? Maybe it is, but if you have this kind of stuff in C++ based on templates and stuff like that, you end up with a very slow and unreadable code. Here we have just an imperative code that generates other code, which is extremely readable, and yeah, it's fine. In C++ it's pretty much possible, but it's as we go further, I'm gonna show what we're gonna use, and in C++ it's always junky. Anyway, so let's continue, whatever. Let's introduce something like OP definition. So, and in OP definition, we have something like OP suffix. Well, since it's already OP, we can just say it's suffix, and the operation itself. So it's going to be just OP. And what kind of stuff we're gonna have? Since we already established that it's nice to have this sort of like enumeration pattern, we might as well have enumeration for this thing as well. So it's gonna be enumeration, OP def type. All right, and what kind of operations we're gonna have in here? So I suppose we're gonna have op def sum, which is initially that, then sub. Right, so this is gonna be sub, multiplication, division. There we go. So, all right, let's create a static thing in here. Op def ops, and of course, count op defs. Count op defs, and what we're gonna have in here? Count op defs. Yeah, op def sum, and here we have a suffix, which is essentially sum, then op, which is essentially plus equals. So that's what we're doing here. So sub is just sub but minus. I wonder if we're gonna add even more in the future. Is it even needed to have something more in the future? Maybe for bit operations? I mean, why not? Yeah, for bit operations. Oh shit, that would be actually super useful. For integer vectors. For integer vectors, like bit operations on integer vectors. Holy shit, that's cool. And you know, in the future, we might as well even generate automatically CMD vectors, right? So, because quite often there is a pattern with like linear algebra stuff when you have a vector that is in fact 4 vectors in a single vector, and you have all of the mathematical operations on 4 vectors simultaneously. We can use also code generation to generate these kind of vectors too in the future. So maybe we're gonna have like a CMD support. We'll see, we'll see. All right, so this one is gonna be multiplication. This is multiplication, and this is going to be something like this, and then we're going to have a division, and this is going to be something like that. Okay, so we have all of this shit in place, and now what I'm going to be doing is I'm going to be iterating op definition type. Oh man, so what's going to be the easiest way to actually work with all of that? So maybe I could call this a type, right? So we're iterating through the type, and maybe this kind of stuff is a type defs, and yeah, so type. Naming is gonna be hard in this one, but anyway. So, oh, and since we have a special type in here, right, so we have a type definition, we might as well actually get op definition in here. So it's going to be op def. There we go. So we accept the size of the vector, the type definition of the element of the vector, and operation definition that you want to generate. So look how many stuff we're accepting in here. That's actually super cool. All right. So that's nice. Okay. So, and in here, we'll have to iterate through op definition type. This one is going to be op 0, op less than count op defs, plus op, and here we have op defs op. There we go. Alrighty. So let's try to recompile the entire thing and see if it works. It's definitely not going to work, but that's kind of the point of using statically typed compiled languages. So here's the op definition. It's going to be suffix. The other one is op definition op. Anything else we have in here? So this is a type defs, and this is because types. This is type defs. Do we have anything else? Type defs, and is it not called op defs? Op. Oh yeah, I called it ops for some reason. Let's call it op defs for the consistency. Okay. Oh, okay. So I have a sum, but here it's a division. Okay, well, let's take a look at what I probably didn't finish the thing. Oh, it's a diff. Okay, so I see what's going on. Okay, that's cool. That's why I'm actually compiling the header that I'm generating. That's literally the reason. This is literally the reason, because then I can catch this kind of errors, right? So in a code generation, it's quite important to just generate and also compile it right away, so you can see and catch these errors like that. That's the beauty of statically typed languages, by the way. So they help you to catch bugs. All right, so that's pretty cool. So we have like a 3-dimension in the generation. Look at that. That's actually pretty epic. 3-dimension in the generation. Ho ho. And to be fair, we already generated like everything that is needed in Wang tiles, right? Well, almost. Because now we have like a very special things, I think. You know what? Before I go into very special things, I think the time has come to maybe you know, commit that, right? Maybe the time has come to commit that. So let me see. So how are we gonna be committing all that? I want this thing to be as an SDP style header only library, right? That's what I want it to be. So that means I'll have to organize that in a slightly different manner, because now I should be able to have the declarations of the functions and the implementations of the functions. So that means I'll have to separate generation of declaration and implementations. So, okay, so we're not really done yet in here. So we'll need a little bit more, if you know what I'm talking about. What are the benefits of doing that, though? We discussed that at the beginning of the stream. So there was a long half-an-hour discussion of why I'm doing all of that. You missed it all. I'm really sorry about it. I'm not repeating that entire discussion. That was actually a pretty good discussion, not gonna lie. Everyone who's been participating and discussing this kind of stuff, thank you very much. It was very, very interesting, but we're not doing it again. We already did it. You have to watch the VOD. I'm really sorry. That's just how stream goes. If we're gonna keep repeating the same thing over and over again, we're never gonna get anything done. So sometimes, quite often, I will just have to, because I don't have any choice, but refer you to the beginning of the stream. I'm really sorry about that. So let's go ahead and maybe do something about the you know, this thing looking like a header-only library. So the thing about header-only libraries, right? So first we need to maybe split the entire thing into a header part and the source code part. Yeah. So the thing about that is SDP style header only libraries are both header and C in a single file. That's what they are. So because of that, we probably need to split this entire thing. So this is going to be header part. And this is basically C part. All right, so there we go. And in here, we're going to do the following thing. It's going to be fprintf std out, if not defined, la h, right, something like this. Then we're going to define this entire thing. There we go. And then we're including stuff. Right, we're including stuff, and then at the end of all of that, we'll have to probably fprintf std out. It's kind of interesting. Maybe we'll be able to extract header part and C part into separate functions, but it doesn't make any sense if you're not reusing these functions over and over again. So I'm not going to do that probably. And if la.h, there we go. So this was the header part, and then down there we're gonna have implementation part, essentially. Okay, so if I try to compile that, so we have a problem here because I forgot a new line yet again. There we go. Seems good, seems Gucci, seems Tamaguchi. Okay, so here's the header part, and then we need to have implementation part. So the thing about implementation part, is that it starts with if you defined LA implementation, only then we include the entire implementation essentially. So I'm gonna put it like that. I think I want to have like an extra new line in here, just in case. Just in case. Then we include all of that stuff in there, and then we need to do and if like so. Right, so we basically enclose the implementation in this thing. Okay, so that already looks more like header-only library, which is nice. And the only reason it compiles is because the LA implementation is not included. But apart from that, it does look exactly like that. So here's the thing. We missing forward declarations in a header part of the file. So we basically need to take these parts and move them in here, but leave the implementations down there. So let me see, leg.c. So the thing about this vec op, it generates implementation. So it generates implementation like this. But it doesn't generate declaration. So one of the things we need to do in here is also have something like decal, right? Yep. And a declaration is basically this, right? But with a semicolon at the end. With a semicolon at the end, which leads me to actually interesting thought. Maybe we should have a separate function, something like again vector op signature, right? Which just generates the signature, and declaration is a signature plus semicolon, and implementation is a signature plus the body of the function. Plus the body of this function. So let's go. Let me see. So this is going to be file stream, and do we need OP definition? I think we need everything, because this is basically a sig, right? So this is basically a sig, but without a semicolon. Without a semicolon, so that means in here I'll have to do something like this. So it's going to be declaration, right? So this is the declaration, and let me see. So we're going to do again vector op sig stream and type def op def, and then fprintf stream, the new line. So it's kind of janky, to be fair. Maybe what I should do instead is return this thing as a short string, if you know what I'm talking about. But now we may suddenly overflow the size of the short string, but I don't know. We'll see about that. But that would be actually nice to use short string for that. I'll think about that, because short strings are very, very small, so we might as well, even if we make them a little bit bigger, if you know what I'm talking about. If we make him like 128, so 128, so it's still gonna be enough, and we might as well return. So this is the vector. So this one is going to be short string. So vector operation signature, right? So this is going to be vector operation signature, and then I can just return short f, think like that. There we go. And that should be enough. Right, so we're starting to have an interesting pattern in here. That gen functions, they print to a particular stream, but these things just give you the a particular signature. Okay, so gen declaration essentially means that I can put s in here, and then I can say vector op signature. So this is vector op signature, and type def op def, and then I just extract the data out of this thing. Right. Wait a second. Why it was changed? Okay, don't ask me that, please. All right, so we don't need that shit anymore. And what we can do in here is just s. So this one is going to be vector op signature, and it's going to be n type def op def. Okay, so that looks good. Looks good. Yeah, it actually looks good. Like it's more readable. So it was a good idea to introduce vector op sig. What do you guys think? Yeah, I think it was, because now it allows me to do this kind of shit. Okay, that's really cool. So again, vector op, so we don't have that shit anymore. So this is again vector op implementations specifically, and it's null. That's very interesting. Okay, let's actually try to find out what happened in there. And why do we have a null in there? That doesn't make any sense to me. If we enable a lot of warnings, one of the problem in here is that we probably don't use enough warnings for this kind of stuff. So let's actually do something like CC, C flags, right? So it's gonna be C flags, and let's enable all of the warnings. W extra, and do we need anything else? I don't think we need anything else, but I might as well use the standard C11. So let me see, it's gonna be pedantic. Chat is very annoying right now, holy shit. Okay, so what do we have in here? Comparison between these things. Yeah, I do be like that sometimes, but I know that the data is probably not gonna overflow. Well, I know this thing is positive, so that means I can just do something like that. Okay. So what else do we have in here? Okay, so that's actually pretty good. So it means I have to do data, and there we go. So we caught that. So I just need to enable, I needed to enable all of the warnings, and that worked well. So here are implementations, and they do in fact compile. So one of the things now that I can do is take this entire thing, right? I just literally copy paste this stuff. And put this thing in here, and instead of implementations, we're gonna use declarations, like that. So let's take a look, and if I go to la.h, here are all of the declarations. Look at that. Isn't that cool? Isn't that cool? I think it's pretty fucking cool. That's actually very, very cool, I'm not gonna lie. Look at that. So, and we usually split by the size of the vector. We can actually do a lot of interesting shit, not gonna lie. So every time we switch to the next size, we can just split it by a new line, right? Right, and are you gonna, yeah, there we go. So here are like different sizes. But we also, it would be also nice to split by different types. I think in this case we want to split by different types. Alright, so let's split on a different type. I think that will make more sense. Yeah, there we go. So here are all of the possible operations and shit. So, yeah. And all that seems to be compiling. But when we're compiling this entire thing, we're not really, you know, enabling LA implementation, if you know what I'm talking about. Right, so let's go to the make file, right, and in here I'm gonna do -z like this, and the language is gonna be C. So this is how I think you have to do that, and that will not compile it into GCH or whatever the fuck it is. I don't even know what it is, and I don't care. Right, it's supposed to, yeah, it's supposed to compile into O file. There we go. So it's actually generated like a final O file. All right. So now we have a thing that generates an actual STB style header only library. That's precisely what it does. That's precisely what it does. So let's go ahead and maybe do a committee. There we go. So maybe I want to actually release everything under MIT license, right? And then we're going to have a readme.md. And so how are we going to be doing all of that? How are we going to be doing all of that? So linear algebra in C, right? Do I need to do anything? So you as the user of this library is not supposed to use lag. That's the thing here. You're not supposed to use lag. You're supposed to grab la.h. Right, so if I want to document stuff, I don't think I'm gonna documenting regeneration or anything like that. So, so readme, quick start. Grab la.h, and use it as an STB style header only library. For more info on such libraries, see, and we're gonna redirect to nothing's STB. Nothing's STB. To where is that thing? So I think it was somewhere in the documentation. I think it was somewhere in the documentation. I think it was like a how-to. All right, so maybe that's a good explanation. Anyway, so people who would be interested in this kind of stuff, they probably heard about this this library. Regenerating la.h. The library is code generated. That's it. You don't need to know anything else. All right, so let's do also git ignore. Right, so this is gonna be lag, and then la.o. Do we need anything else? I don't think so. Okay. I don't think so. And let's do git init. There we go. Let's git init. And this is gonna be ready, set, go. And let's go ahead and just create a repo for this kind of thing. Invite someone. Who should I invite? LA. Linear algebra in C. This one is going to be public. And I'm going to just simply add origin. Boom. And we're going to push that right into the repo mate. Right into the repo mate. And you can find the shit in here. And if you are watching on YouTube, I'm gonna put that in the description as well. Right. So source code. Let's actually put it in here. Yeah, there we go. Cool. So yep. We're almost done, by the way. We're almost done. So there is a few things that we still need to finish. I really like how the size of the library grows combinatorially. It's basically combinatorial growth. So in LA, right, I usually use other special functions. For instance, vec2f sqrt, which accepts like a single thing here, right? And basically applies sqrt to each individual component in here, right? It applies sqrt to each individual one and returns the result. So, yep, we need to have something like this as well. So, yeah, len and some other things. There's a lot of things that we need to add in here. So let me actually think. And we also need constructors. Yeah, we also need different constructors. All right. We also need different constructors. Maybe I'm gonna start adding to-dos. Generate regular constructors for the vectors, right? Things like vec and t. So nt stands for like, you know, size and type. And this thing is gonna accept like t, a1, t, a2, and so on and so forth. So we also need to generate scalar constructors for the for vectors, scalar constructor for vectors, and they will look like, well, I mean, this thing is sort of like parameterized, right? So and they will look like this with s at the end, and they always accept a single thing in here. So basically they take a single scalar and they extend it to the whole vector. So that's basically what they're doing. These constructors are very important, actually. Okay. So another thing, sqrt operation for vectors, right? So we may actually go to rank tiles just to see what are the other operations we want to have in there, right? So if I, yeah, it was a later C. So what are the operations we need in here? Don't quite remember. We need power operation, right? So we have a sqrt, we have power, lerp operation, that's for sure. Length, that's important. So interestingly enough, not all of the operations are applicable to all vectors. sqrt is only applicable to floating point vectors, but not really to the integer vectors. So we also need some sort of information to encode that, okay, some of the types we have in there are integers and some of them are floats. Some operations can only work on floats, some of them may only work on integers, and so on and so forth. So, and using C programming language directly actually makes it super flexible, because now we can build up different tables. Yeah, but we actually rising the level of abstraction even further. We're on the levels which are not really possible with the C preprocessor. Like, we're doing like a lot of very complicated shit, and it justifies using code generation more and more as I go, which is actually super cool. So we also want to have a min and max, right? So we want to have a min and then max, which is applicable to comparables. Maybe we're going to have something like comparable types, but all of the types we're using right now, they're comparable. So there's no need to do that, but maybe in the future we're going to have not comparable types. So, okay, so apart from that, we have this kind of thing, right? There's no need to say generate. So another thing is that matrices. Is that how we spell that? I think this is how we spell that. So at some point we're gonna also add support for matrices, and it's also gonna be very much interesting. So I'm already streaming for 2 hours. And I think you got the gist of the idea for this specific project. So I'm gonna go ahead and commit the to-dos, the rest of the work, right? And I suppose I'm gonna actually call it a day because I didn't want to make like a very long stream. But yeah, so I showed the idea that I wanted to implement, and I showed how this entire idea is going to scale in the future. So in the future you can add more and more different tables in here, and maybe we're gonna do another episode of this series, like of LA generation, or maybe not, because I don't know. It's sort of like, yeah, that's what you do. So you just need to keep expanding this code generator, and yeah, and keep using it. All right, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on the next episode of something. I don't know. We'll see what's going to be the topic. And yeah, check out the source code of the project if you're interested in it. And maybe like I'll probably need to put like a justification for doing it this way, because people keep asking the same questions over and over again, like why you would do that, why you would do that, why don't you use Rust, why don't you use that. So even though we discussed that at the beginning of the stream, so maybe I'm gonna put like justification here in a readme, or maybe just give a link to the description itself. We'll see how it goes. So yeah, and if you're watching it on YouTube, check out the description. I put all of the necessary stuff in the description that we were discussing today, and I gotta go. Thanks everyone who's watching me. Love you all. Mwah.